So if I take an object that's traveling in a circle some distance r here, so it travels around, traveling in a circle, so it's a constant distance away from here, traveling in that direction. Let's go ahead, I'm going to change that. So we got some position here, r here. Let's have it traveling in that direction, in classic clockwise direction, traveling around a circle. That is the velocity. This is at some angle theta, and that's some distance r. And so my position is r cosine theta I hat minus r sine theta j hat plus r sine theta j hat. Classic unit circle kind of stuff. My velocity, though, is perpendicular to that. And so if that angle is theta there, that angle is theta there, and this angle here is the complement of theta, which I will label as theta prime. So theta plus theta prime is equal to 90 degrees, or for those who are cool, pi over 2. And it is traveling, if I establish my coordinate system, which I should have done beforehand. So that is in the negative I hat direction. And so negative v cosine theta prime I hat plus v sine theta prime j hat. And remember that complements, the sine and cosine can flip. And so this becomes negative v sine theta I hat plus v cosine theta j hat. Again, what I was saying there is that sine theta prime is equal to cosine of theta, and cosine theta prime is equal to sine of theta. Well, actually, we can derive this. We don't have to think through it. We can just do some math here. I know that v is the time derivative of s. So this becomes d dt of r cosine theta I hat plus r sine theta j hat. So r and I hat are constants, and so what's changing is this. So it's the derivative of cosine theta is derivative of cosine is negative sine. So this is negative sine theta times theta dot, the derivative of theta with respect to time, r I hat plus r cosine theta, theta dot j hat and, well, it's got to be equal to that. So this theta dot is the derivative of theta. Well, I know that s is equal to r theta. I know that s dot would be equal to r theta dot. This is the arc length is equal to the radius times the angle subtended. This is v, and this is r theta dot, and so we have v over r. This is just v over r. And I don't want to quite make that substitution yet. This theta dot is also equal to something called angular velocity. If that's a vector, actually theta is just an angle, so there'd be angular speed. So we're left with negative omega r I hat sine theta plus r omega cosine theta, that's I hat and j hat. I know acceleration is the derivative of that, and omega is constant, r is constant, I hat's constant. Oops, that's too many I hats. I hat's constant. Those are all constant, so I get negative omega r, well, derivative of sine is cosine, so this is cosine theta, theta dot I hat, plus, and then here we have a bunch of constants, so this is r omega negative sine theta, theta dot j hat, which is negative omega r, well, don't forget that's omega, so it's negative omega squared r cosine theta I hat minus over here r omega squared sine theta j hat I can factor, I have the same factor here, so this is negative omega squared r times cosine theta I hat minus plus sine theta j hat. Well, that is just this unit vector pointing in that direction. So this is negative omega squared r hat. Omega squared, I know the omega is, the v is equal to r times omega, or omega times r. So omega is v over r. Pop that in here, and we get negative v squared over r squared times r hat, which is negative v squared over r hat. And that right there, v squared over r, is known as centripetal acceleration. I guess technically that is the magnitude of the centripetal acceleration, which is v squared over r. The whole thing is the centripetal acceleration. And so centripetal acceleration is, well, just rewriting that, a little less messy, negative v squared over r hat. Don't forget, r hat is a unit vector away from the center. Negative r hat would mean it's pointing towards the center.